As always, watch this video 3 times at least to make sure that you have a method for your practical lesson tomorrow written down very, very carefully, and that you understand that method. Also, even more importantly, make sure that you understand the risk assessment that is included after the method in this video, so that you're sure that you understand the hazards, what's dangerous, and also the mitigation. That means how to protect yourself and others from being injured. If after watching this video 2 or 3 times you've still got questions, then you need to arrive in class ready to get your questions addressed before you begin. We want to do that really quickly so that, of course, you have as much time as possible to experiment in the lab. The aim of this investigation is to demonstrate that mass is conserved in a chemical reaction. So that means that as the reaction proceeds, matter isn't created, but it isn't destroyed either. So we want to show that the mass of all of our reactants is equal to the mass of all of our products when we're done. To begin with, measure 200 milliliters of hydrochloric acid into a conical flask. Now remember, the lines that you see on the sides of a conical flask are not accurate measures of volume, and those are not what you should be relying on. Instead, get yourself a measuring cylinder. It might mean that you need to measure, for example, 4 lots of 50 milliliters or 2 lots of 100 milliliters and pour them into your conical flask as you go. But don't rely, as I say, on the sides of the conical flask, because those are really, really inaccurate measures. Also, measure 2 grams of solid sodium carbonate into a plastic weigh boat using an electronic scale. The best way to do that is to begin by putting the empty weigh boat on the scale. Then hit the tare function on the scale itself. That will ask the scale to disregard the weight of the weigh boat. Then, once the reading says 0.00 with the weigh boat on top, then you can start spooning in your calcium carbonate until the reading on your scale says about 2 grams. Don't spend 20 minutes making sure that it says exactly 2 grams, because there's no need for that. If the scale says 1.8 grams, that's good enough. And if it says 2.2 or even 2.4 grams of calcium carbonate, that's also good enough. Okay, so you're looking for about 2 grams of calcium carbonate. Now, this third step is really important, and this is where people make mistakes every year. Next, you need to place the conical flask, the weigh boat, including its calcium carbonate, and an empty balloon back onto the scale. All of those 3 things together on the scale at one time, and record their collective weight. That means record the weight of all 3 of them. Make sure you understand that step before you go any further. Finally, come away from the scale. Working very quickly, pour your powdered calcium carbonate into the conical flask, just on top of the acid, and cover the lip of the flask with your balloon. Okay, that bit needs to be done really quickly so that you capture all of the gas that's produced during this chemical reaction. You might need to hold the edge of the balloon around the lip of the conical flask with your fingers to make sure that it doesn't pop off as the reaction proceeds. Then wait until the reaction has finished. That means there's no more bubbling in the acid. Then, once the reaction is done, place your conical flask with the balloon still attached back onto the scale. But with that, you need to put your now empty weigh boat back on the scale, so don't throw it away. after the reaction, I'm saying this again, after the reaction is done, place your conical flask with the balloon still attached and your empty weigh boat back on the scale and record their collective weight all together. Then remove the balloon, place everything back on the scale, and record their mass one final time. So this is giving you what you're being asked to record the mass 3 different times. The first time, you're recording the mass of the conical flask, the weigh boat, the calcium carbonate, and the balloon before the reaction has started. Then you record the weight of all of those things after the reaction has finished with the balloon still attached. Finally, in step number 7, you're recording their weight with the balloon not attached. By this stage, in step number 7, by removing the balloon, you've allowed the the carbon dioxide produced in your chemical reaction to escape out into the air. Okay, but I want you to show that again by weighing it for a 3rd time. Finally, cleanup. The cleanup here is really easy. You can throw your balloon in the bin. You can tip all of your reaction down the sink. You can place the weigh boat and the glassware in the blue dirty glassware bucket at the back of the room. As for your risk assessment, there are no surprises here. Hydrochloric acid is very corrosive. It can burn the eyes especially and irritate the skin. Also, broken glassware can cut your fingers. So how will you mitigate the risk? That means, what will you do to minimize the chances that you or somebody else could get hurt? First of all, most importantly, you wear safety glasses at all times. You only take your safety glasses off after everybody is finished experimenting in the lab, or after you've left the lab and gone back to your desk. Also, report all breakages to me immediately. Don't try to clean them up yourself. Just report them to me and I'll clean them up, and that way you can't get cut. And that's all.